Hi everyone. So in this question, we're going to do an example of an elevator problem and how our apparent weight might change during an elevator ride. So in this question, an elevator starts from rest on the first floor. It's going to speed up at an acceleration of 1.5 meters per second squares for 3 seconds. Then it's going to go at a constant velocity, and then it's going to slow down at 1 meters per second squares until it reaches the stop on the 5th floor. So what I'm trying to figure out is that, first of all, I want to see what a velocity time graph, a position time graph, and an acceleration time graph is going to look like for this question. Then I'm going to actually calculate my apparent weight at 3 different sections of this journey. Now, for the sake of simplicity, let me start with a velocity time graph. So if this is my velocity time graph, I know that for the first 3 seconds, I'm speeding up. And since I'm speeding up, it means that my velocity is actually increasing with time. So as time goes by, my velocity is going to increase at a constant rate. So then I know that I'm going to have a straight line like that. Then it says that thereafter it moves with a constant velocity. A constant velocity means that my velocity is not changing with time, so it stays at whatever it was before. It doesn't mean that it's zero. It means that it's going to be constant. So it will, if the value is, let's say, 5 meters per second, like let's say over here, it will stay 5 meters per second. Well, in this question, there's no value, so I'm just going to assume it has just a random value. So it's going to stay at a constant rate. Then it starts slowing down. So what does it mean to slow down? Meaning that my velocity is going to decrease with time. So let me change this a little bit. It's actually going to decrease with time until it hits 0, which is my velocity is 0 here, right? That's basically what's happening. Now, off of this graph, I want to show you how to do a position time graph and an acceleration time graph. So here's my position time graph. So what I know is that the velocity time graph is the slope of a position time graph. So it's the slope of the second one. So what can I have for the first section of my motion? So for this one part, right? So it will give me a slope of an increasing slope that I have here. As you saw in my previous video, only a curve with a positive slope such as this one will represent and will have a slope like that. So my position time graph is going to look like this. I'm just going to do a quick explanation. Why does this curve have a positive slope? It's because if I drew 2 lines here, tangent to the curve, and then try to find the slope and see how the slope is changing. Since this one, the second one, has a higher slope, that means that my velocity or my slope is increasing here. So that's why this represents as increasing or a positive slope. Now for the second part, all I have is a constant velocity. So what should I have had? I should have had a straight line with a positive slope to give me a constant velocity. So if I had a straight line like that with a positive slope, the slope of that would look like this. So therefore I can draw that. Now for the last part, I actually have it slowing down. So what kind of curve would represent a slowing down slope? A curve like that maybe, right? If I have the same 2 points here and I have my tangents to these points, I see that the second one has a smaller slope than the first one. Therefore, my slope is decreasing. Therefore, the slope that represents this curve is going to look like that. So, which is going to be the same as here. So I'm going to have a curve that goes like that. If I were to draw this smoothly, it would look like this, right? Perfect. Now let's take a look at the acceleration time graph. Looking at the acceleration time graph, it's actually easier to take it out of the the velocity time graph. So the acceleration time graph is the slope of the velocity time graph. So this one is going to be the easiest graph to conduct because the slope of the first part here is going to be a positive number. So I'm just going to draw it as a positive constant because the slope of this one is just a constant number, right? The slope of the second part here is just 0 because the slope of the horizontal line is 0. So I'm going to draw that as a 0 acceleration. And for the third part, I have a negative slope, therefore my acceleration is going to be a negative number because acceleration is the slope of the velocity time graph. Now that we have our graphs sorted out, we're going to actually try to figure out what the apparent weight is in the 3 sections. So let's say if we do the first part, which is accelerating up. So to do this, I'm going to use the same formula we got on my first video on this subject. So I'm going to use N equals MA plus G. Then I'm going to plug in my numbers for my 3, parts of the motion. So the first part, I'm accelerating. So my apparent weight is equal to 60 kilograms times A, which is 1.5 meters per second squared plus 9.81 meters per second squared. Putting that all into my calculator, I am going to get 678.6 newtons. Now for the second part of my motion, I'm going to use the same formula. So my apparent weight is going to equal what? My mass, which is 60 times acceleration. So the second part, my velocity is constant. What does the constant velocity mean? Constant velocity is basically the same thing as saying acceleration is 0. So I'm going to put 0 for my acceleration plus 9.81. Putting that into my calculator, I get 589 or 580, I would say 88.6 newtons. Now for the third part of my motion, I actually have my elevator slowing down, meaning my acceleration is going to be a negative 1 meters per second squared. Plugging it into the same equation, I will get 60 times minus 1 plus 9.81. So in the bracket, I will have 8.81 meters per second squared. And my final answer here would be 528.6 newtons. That's basically it. Now, if I look at my values for the first part here, and the second part and the third part, the second one represents a 0 acceleration, meaning my true weight. Right, so this represents my true weight. If I were to step on a scale, it would show 60 kilograms. If I multiply it by 9.81, it will give me 588.6. So that's actually how much I weigh truly on planet Earth, right? Now this one, on the first one, when I'm actually speeding up, which I have a positive acceleration, I have a heavier weight. And this one, when I'm slowing down, it actually gives me a smaller weight. So it's 528, which is a smaller number than my true weight. What does it mean? So let's say if I'm actually on an elevator and an elevator is actually going to speed up, as soon as it starts accelerating, if I'm sitting down on an elevator and try to get up, it's going to be heavier. You can try it next time when you are on an elevator. Sit when you actually put in your floor and try to get up as the elevator starts moving faster. Then you will feel that it's so heavy and it's a lot harder to get up than you would normally get up, on the ground. And same thing as here, so you would actually feel lighter if you were trying to get up as the elevator is actually slowing down and reaching your floor. That's about it. I hope you enjoyed the video. So if you liked it, like, subscribe, and share it with your friends. Thank you so much.